Steel, concrete. These are the titans of construction. We see them and we think of permanence, of unyielding strength. When you look at the skeleton of a skyscraper reaching for the clouds, or the solid foundation of a home, there's an inherent sense of security. It feels indestructible. But is that feeling of safety an illusion? We've been taught to believe that strength is simply a property of the material, that using the thickest beams and the densest concrete automatically guarantees a building that can withstand any challenge. This is one of the most pervasive and dangerous myths in the world of construction. The common assumption is that if you hire a builder who uses high-quality, robust materials, you've done your due diligence. But what if the blueprint they're following is fundamentally flawed? The truth is, poor design can turn the strongest materials into a catastrophic liability. A building is not just a collection of strong parts, it's a complex, interconnected system. And when that system is designed incorrectly, failure isn't a matter of if, but when. Let's dismantle some common myths. Myth number 1, thicker is always better. In reality, just adding bulk can introduce new problems. It adds immense weight that the rest of the structure and the foundation must support. Smart engineering is about efficiency, using the right amount of material in the right shape and the right place. It's about elegance, not just brute force. Myth number 2, the builder is the expert on safety. While a skilled builder is crucial for execution, their expertise is in construction methods. The structural engineer is the one who designs the system, who calculates the forces, and who ensures the building can stand up to them. They are two separate, vital professions. To understand why design is paramount, we need only look at history. These aren't tales of weak materials. They are cautionary tales of flawed design. Consider the Hyatt Regency walkway. Collapse in Kansas City in 1981. Two vertically stacked walkways, suspended from the ceiling by steel rods, fell onto a crowded lobby below. The investigation revealed a critical design change made during construction. The original design called for a single set of long rods to hold both walkways. The fabricated design, however, used two shorter rods. This seemingly minor alteration doubled the load on the connection supporting the upper walkway. The steel rods themselves were more than strong enough. The beams were strong enough. But the design of the connection, a detail on a drawing, created a point of failure that led to tragedy. It was a failure of communication and a catastrophic failure of design detail. Or take the case of the Sampoong department store in South Korea, which collapsed in 1995. This wasn't a single error, but a cascade of disastrous design decisions. The building was originally designed as a 4-story office building. The owner decided to change it into a department store, which has significantly heavier load requirements. To maximize retail space, crucial support columns were removed to install escalators. Then, a 5th floor was added, which the original structure was never designed to support. To make matters worse, 3 massive 15-ton air conditioning units on the roof were dragged into a new position instead of being lifted by a crane, sending deep cracks through the already overstressed roof slab. The materials didn't stand a chance. They were systematically compromised by a design that was altered, ignored, and pushed far beyond its limits. So, what is the secret language of engineering that prevents these disasters? A core principle is the concept of load paths. Imagine the weight of a building, its occupants, and even snow on its roof as water. That water needs a clear, uninterrupted path to flow down to the ground, the foundation. Every beam, column, and wall is part of this riverbed. If you remove a column, you've just built a dam. The load, or water, has to go somewhere. It will try to find a new path, stressing parts of the building that were never intended to carry it. A good design ensures these load paths are clear, direct, and robust. Another key principle is redundancy. This is essentially a structural plan B. Instead of relying on a single element to hold everything up, a redundant design distributes loads across multiple elements. If one component fails, others can pick up the slack, preventing a localized failure from turning into a progressive collapse of the entire structure. It's the difference between standing on a single tree branch versus a web of interconnected branches. And no building is an island. It must interact with the ground beneath it. This is where foundation design and soil analysis come in. A building is only as stable as the earth it rests upon. Engineers conduct soil tests to understand its composition, density, and ability to bear weight. Is it solid bedrock, soft clay, or sandy soil? The foundation is then specifically designed to work with those conditions. A skyscraper in a city with soft soil might sit on hundreds of deep piles driven down to bedrock, while a house on stable ground might have a simple concrete slab. Using the wrong foundation is like building a castle on sand. Even the most brilliant design is just a piece of paper without proper execution. This is where quality assurance and inspection become non-negotiable. The Hyatt walkway collapse wasn't just a design flaw. It was a failure to ensure the final construction matched the safe, intended design. On a safe construction site, independent inspectors act as the guardians of the design. They verify rebar spacing before concrete is poured. They check the torque on every critical bolt, and they approve welding quality. They ensure the builders are following the engineer's instructions to the letter. This rigorous oversight bridges the gap between blueprint and reality. As a property owner, whether you're building a new home or renovating an existing one, you are the team captain. Your most important decision is hiring the right professionals. So how do you choose a qualified engineer? First, verify their credentials. Look for a PE after their name, which stands for Professional Engineer, or SE for Structural Engineer. This means they are licensed by the state and are held to a high professional and ethical standard. Second, ask for their portfolio and references, specifically for projects similar to yours. An expert in high-rise buildings may not be the best fit for a residential timber frame. Third, ensure they carry professional liability insurance. This protects you and demonstrates that they are a serious professional. Finally, discuss their process. How often will they visit the site? How do they coordinate with the builder and inspectors? A good engineer is a partner in the process, not just a signature on a drawing. You don't need to be an expert to review the plans, but you can ask intelligent questions that promote accountability. Ask your engineer, can you walk me through the primary load paths in this design? What are the most critical connection points, and how are they being handled? What were the results of the soil report, and how does the foundation design address them? Asking these questions shows you are an engaged owner and encourages the entire team to remain diligent. Finally, remember that a building's life doesn't stop when construction ends. It needs to be maintained. Pay attention to the signs your building gives you. Are new, large cracks appearing in the foundation or walls, especially ones that are wider at the top than the bottom? Are floors beginning to sag? Do doors and windows suddenly stick or refuse to close? These can be signs of settlement or structural distress. Just as you'd see a doctor for a persistent pain, you should consult an engineer if you notice significant changes in your building, especially after events like earthquakes, floods, or major renovations. The strength of our buildings is not found in the size of their beams or the thickness of their walls. It's found in the intelligence of their design, the integrity of their connections, the stability of their foundations, and the diligence of their construction and maintenance. A safe building is a holistic system, a symphony of forces and materials working in perfect harmony. By understanding these principles, you can champion smarter, safer construction for yourself and your community. Stronger buildings come from smart engineering. Subscribe for more myths busted. Do your own research and make sure everything is correct and detailed.